All right, our first word problem. Josh asked a bank teller to cash a $230 check using $10 bills and $20 bills. If the teller gave him a total of 15 bills, how many of each type of bill did he receive? All right, first thing we're going to do is define our variables. I'll go ahead and use X and Y. So I'm going to let X equal the number of $10 bills. I'm going to let Y equal the number of $20 bills. Okay, so first, he's given 15 bills total. So if you take the number of $10 bills plus the number of $20 bills, it's going to equal 15. So there's one equation. Now we need another equation that uses all of these dollar amounts. It's a total of $230 using $10 bills and $20 bills. So it's $10 for every $10 bill. In addition to that, he has $20 for every $20 bill, giving him a total of $230. So there's our second equation. Now what we're going to do is solve the equation using substitution or elimination. Honestly, you can use either one, whichever one seems easier to you. For me, I see the X's are lined up, the Y's are lined up. It makes me think of elimination right away. I can multiply this top equation by a negative 10. What that's going to do is give me a negative 10x, which will cancel with the positive 10x. And then elimination is going to work quite nicely on this. So I rewrite the problem down here, negative 10x plus a negative 10y or minus 10y equals negative 150. I'll just carry down the second equation, 10x plus 20y equals 230. And now we're ready to add these equations together. So we're using elimination. Negative 10x plus 10x cancels away, it equals 0. Negative 10y plus 20y is 10y equals negative 150 plus 230 is a positive 80. And then we just divide both sides by 10 and we get y equals 8. So that tells us that he has 8 $20 bills. So we're going to take that 8 and plug it back in. I do think the top equation, this x plus y equals 15, is the easiest equation to work with. Now that we know that y is equal to an 8, we're going to say x plus 8 equals 15. Subtract that 8 from both sides and we get y equals 7. So to answer the question, who is this, Josh? I already forgot. Josh has, oops, that's supposed to be an X. Josh has 7 $10 bills and 8 $20 bills. See how I answered that with a nice sentence? Let's do that. All right, our second example, tickets for the homecoming dance. Well, that's timely, isn't it? Cost $15 for a single ticket and $25 for a couple. Ticket sales totaled $1,950 and 145 people attended. How many tickets of each type were sold? So first we define our variables. I'm just going to use X and Y again. So X is going to equal the number of single tickets sold. And Y is going to equal the number of couple or couples tickets. All right, so our two equations, if you get kind of stuck on what are the equations going to be, look for your total numbers. I can see that the sales totaled $1,950, so all of my dollar values are going to probably go in that equation, $15 and $25. It's going to total $1,950. I also have a total number of people attending. So I'm going to start with the number of people attending. We have 145 total people. So X is my total number of single tickets. So if I sold 20 single tickets, that means there's 20 people. We also sold couples tickets. Well, how many people are involved in a couple's tickets? That's going to be 2 people per ticket. So I'm going to say 2 times Y, the number of couples tickets. So for example, if I sold 5 couples tickets, 5 times 2 tells me there were 10 people, okay? And the total number of people that attended were 145. This does not sound like it was a Rockford homecoming. This is a small homecoming dance. All right, now let's look at our dollar amounts. We know that it costs $15 for a single ticket. So we're going to say $15 times every single ticket. And it also costs $25 for every couple's ticket. So $25 times every Y. I added those two together because we have a total sale value of $19.50. Okay, now we can solve this with substitution or elimination. I see this X right here. It's a lonely X all by itself. Substitution actually will work quite nicely anytime you have a lonely variable. So I have X plus 2Y equals 145. I'm just going to subtract the 2Y. So I have X equals negative 2Y plus 145. So X equals this. So what can I do with this? Plug it into the X of the other equation. So 15 times negative 2Y plus 145 plus 25Y equals 1950. All right, when we solve, we're going to go ahead and distribute that 15. So negative 30Y plus 145 times 15, 2,175 plus 25Y equals 1950. Combine like terms. A negative 30Y plus a 25Y is a negative 5Y plus 2175 equals 1950. And then we subtract. So we have negative 5Y equals negative 225. Divide both sides by negative 5. And Y equals 45. So that means that there were 45 couples tickets sold. Now to get the number of single tickets sold, all we do is we take this 45. When you use substitution, it's really easy to see where to plug it back into. Just look for that box that you did from the beginning. So our number of single tickets is equal to negative 2 times our Y, which is 45, plus 145. So negative 90 plus 145. And we get 55. So let's answer the question. There were 55, single tickets sold and 45 couples. Tickets sold. And that answers the question.